Good evening. Would you like to introduce yourself to the audience and tell them about your experiment?
Yes, my name is Sir JJ Thomson of the University of Cambridge. I designed what is now known as the cathode ray experiment that is well known in physicist circles. I was awarded a Nobel Prize for this experiment in 1906.
What were you trying to do with this experiment and how did it work?
Colleagues of mine and physicists of the time seemed to believe that the process behind the cathode ray tube was a wave. I thought it was a particle. And so I designed this experiment to prove my hypothesis. And upon running my experiment, I found that my hypothesis was correct. The method I ran this experiment was in 3 parts. The first part showed that the waves or particles, ray, whatever you want to call it, was always the same no matter the cathode or gas in the tube used. And this was on track with my hypothesis. So I moved on to the second part of my experiment, for which I have a diagram set up shown here. You see, I directed a beam of these particles or waves through a cathode ray tube. And these charged plates interacted with the ray and it was deflected towards the positive charged plate. This shows that these particles or waves had a negative charge, and I could measure this negative charge using a scale on my cathode ray and a fluorescent lining on the tube. And so discovering that these could be deflected and that this wave and its charge were inseparable, I discovered that these rays had to carry their charge and were inseparable. So I moved to the third part of my experiment, where I ascertained the exact mass to charge ratio of these so-called particles using the same tube I just showed in my diagram. And all of this came together to prove my hypothesis that it was in fact particles behind this cathode ray phenomenon and not just a wave of energy.
Where did you do this experiment?
This experiment took place at my laboratory, the Cavendish Laboratory at the University of Cambridge, in England, of course, in April of 1897.
What other significant discoveries were happening when your experiment took place?
I built off the work of such men as Prout and Lockyer, well-known physicists, and Mr. William Crookes. Prout and Lockyer had proposed that the atom was made of subatomic particles smaller than just atoms. And I agreed with them, but they thought the smallest was the element hydrogen. I thought there were even smaller particles, what would become known as the corpuscle and the proton. And Mr. Crook was instrumental because he designed the cathode ray tube that I used for my experiment. He was also my colleague and my predecessor at the University of Cambridge. Along with this, William Röntgen had recently discovered the X-ray in his experiments in his own lab in Germany. And so I built off these men's work.
Who else was involved in this project?
Several of my students helped with the project, but I primarily conducted it on my own.
What was your role in this project?
I was the leader and principal designer of this project.
What impact do you feel your project had on the physics community?
I would like to think my impact was significant. The corpuscle, what is now known as the electron, was instrumental in Mr. Robert Millikan's work, the American physicist who discovered the exact mass and charge of the electron just a few years after my own experiment. Millikan's experiment would then lead to my own student, Ernest Rutherford's, proposal of the new model of the atom, the one we use to this day. So I think I was used as a stepping stone in physics, much like I had used the men before me. And so I hope that my work will come to be seen as significant in the following years.
What are you most proud of in your physics career?
Certainly the thing I'm most proud of is my students. I've had 7 students get a Nobel Prize, and even more be known among the world's greatest physicists, such as Anton Francis and Ernest Rutherford, who will surely be known as some of the greatest scientists of their time.
Thank you for your time, Mr. Thompson, and have a good evening.
Have a good evening.